Good morning. On the last period we have started dual nature of radiation and matter. At that time we have seen photoelectric effect. The phenomenon of emission of electron from matter when exposed in a light of suitable frequency is called as photoelectric effect. त्यानंतर experimental study of photoelectric effect. Observations. पहिलं variation of frequency, threshold frequency. The minimum frequency must be required for emission of photoelectron, called as threshold frequency. Second observation, rate of emission of photoelectron is directly proportional to intensity of incident radiation. त्यानंतर maximum current or saturation current in photoelectric effect depends upon intensity, and stopping potential depends upon frequency of incident radiations. One more, that is photoelectric effect is an instantaneous process, means there is no time lag between incident radiation and emission of photoelectrons. त्यानंतर आपण दोन फेल्युअर पाहिले होते व्यू थिअरी. पहिले इन्स्टंटेनियस इफेक्ट आणि दुसरं एनर्जी ऑफ इजेक्टेड इलेक्ट्रॉन्स. त्याच्यात थोडं पुढे जाऊन आपण पाहतोय आइन्स्टाईन्स फोटोइलेक्ट्रिक इक्वेशन. आइन्स्टाईन्स EISTEINS Einstein's photoelectric equation. Einstein's photoelectric equation. In 1905, Einstein explained all the features of photoelectric effect on the basis of Planck quantum theory. Planck's quantum theory. In 1905, Einstein explained all the features of photoelectric effect on the basis of Planck quantum theory. As like, first point, incident radiations contains photons. Incident radiations contains photons and release the energy in the form of quanta, QUANTA. According to Planck quantum theory, incident radiations contains photons and these photons release energy in the form of quanta. When radiations of suitable frequency incident on metal, then these photons, suppose this one as metal, these are some electrons of metal. When radiations of suitable frequency incident on metal, then these photons collapse on electron and transfer their energy to that of electrons, due to which electrons are emitted. The energy transferred by photons to electrons, see, if H, that is Planck constant, mu, that is frequency of incident radiations, if H Planck constant, mu frequency of radiations, then energy of photons, then energy of photon is equal to H mu. Means when photons collapse on electrons, when these photons collide on electrons, then energy of photon h mu transferred to electron. This energy, the energy transferred by photon to electron, this energy is usually into two parts. One, that is part of energy used for emission of electrons from matter. The energy or the minimum energy required for emission of electrons from photon is called as photoelectric work function. Means the energy of photons is transferred to the energy of electrons. This transferred energy is usually into two parts. Part of energy is used for emission of electrons from matter. This energy is called as photoelectric work function. What is photoelectric work function? The minimum amount of energy required for emission of photoelectrons from matter is called as photoelectric work function, and remaining part of energy is used as kinetic energy of electrons. And therefore, if suppose m mass of electron, phi that is velocity of electron, phi photoelectric work function, phi naught that is photoelectric work function, then energy lost by photons is equal to energy absorbed by photons. Means energy lost by photons is equal to energy absorbed by photons. Energy lost by photons h mu. Energy absorbed by photon is usually into two parts, that is, part of energy is used for emission of photoelectron is called as photoelectric work function, and remaining energy as kinetic energy, that is 1/2 m v square. Remaining part, that is m v square. With this energy, electron moves with maximum energy, and therefore velocity of that electron, that is phi max. This is Einstein's photoelectric equation. Einstein's photoelectric equation. This is Einstein's photoelectric equation. What is that? The energy of photon h mu is equal to photoelectric work function plus maximum kinetic energy. If suppose mu is equal to mu naught, means frequency of incident radiations is equal to threshold frequency, then electrons are emitted with zero kinetic energy, means just electrons are emitted, and hence kinetic energy of that electrons become zero. At threshold frequency, electrons are just emitted from metal surface, and hence its kinetic energy is zero. Therefore, this equation becomes h mu, that is mu naught, is equal to phi naught plus kinetic energy 0, and therefore photoelectric work function phi naught is equal to h mu naught. मिळालेली व्हॅल्यू समजा आपण इथं ठेवली तर मग maximum kinetic energy, that is 1/2 m v max square is equal to maximum kinetic energy h mu minus phi naught heater h mu minus h mu naught. Therefore 1/2 m v max square is equal to, समजा h ला कॉमन काढलं तर mu minus mu naught. सपोज दिस इज आवर इक्वेशन नंबर 1. ही एक आपल्यासाठी महत्वाची इक्वेशन आहे. ह्या इक्वेशनला म्हणतात आइन्स्टाईन्स फोटो इलेक्ट्रिक इक्वेशन. If frequency of incident radiations is equal to threshold frequency, then photoelectrons are just emitted, and hence kinetic energy becomes 0, and therefore maximum kinetic energy h mu minus mu naught. From this equation, we have to Einstein explain characteristics of photoelectric effect. From this equation, Einstein explained characteristics of photoelectric wave first. From this above equation, if suppose mu is greater than mu naught, second mu is equal to mu naught, and third one mu is less than mu naught. From this equation, if mu is greater than mu naught, then this term is positive, means kinetic energy of electron is greater than 0, means positive, means electrons are emitted with certain kinetic energy. If mu is equal to mu naught, then this term becomes 0, means kinetic energy of ejected electron 0, means electrons are just emitted from matter. And if mu is less than mu naught, then kinetic energy is less than 0, means electrons does not emitted. Thus from these three cases, minimum threshold frequency must be required for emission of photoelectrons, and that frequency is called as threshold frequency. Means for emission of photoelectrons, frequency of incident radiations must be equal or greater than threshold frequency. From this equation, minimum threshold frequency must be necessary for emission of photoelectrons. Now second characteristics about intensity. According to Planck quantum theory, more intense beam contains more electrons. More intense beam contains more photons, and hence rate of emission of photoelectron is directly proportional to intensity of incident radiations. According to Planck quantum theory, more intense beam, म्हणजे ज्या बीमची इंटेन्सिटी मोर असते, जास्त असते, त्यामध्ये जास्त फोटॉन्स असतात, and hence more energy transferred to that of electron, and more number of electrons are emitted from matter. Means rate of emission of photoelectron is directly proportional to intensity. Third one, if collector is given positive potential, with respect to anode or with respect to emitter, then electrons emitted from emitter are accelerated towards collector. As collector potential increases, more and more electrons are attracted towards it and photoelectric current increases. But intensity of incident radiations determines number of photoelectrons are emitted, and hence even if positive potential increases, photoelectric current remains constant. If intensity increases, then number of photoelectrons emitted from metal also increases, and hence saturation current increases. Thus, saturation current depends upon intensity of incident radiations but not frequency. Fourth one. In this equation, as H and mu are constant, from this equation, as H and mu naught are constant, maximum kinetic energy of ejected electron depends upon frequency of incident radiations. From this equation, as H and mu naught are constant, the maximum kinetic energy of ejected electron depends upon frequency of incident radiations. Fifth one, that is maximum kinetic energy of ejected electrons, that is 1/2 mv max square is equal to stopping potential into charge. समजा ही व्हॅल्यू आपण इथे घेतली तर मग V naught is equal to V naught into E is equal to H mu minus H mu naught, and therefore V naught is equal to stopping potential. V naught is equal to E ने डिवाइड केलं तर H mu divided by E minus H mu naught divided by E. And this is nothing but photoelectric work function, that is H mu divided by E minus phi divided by E. Thus, stopping potential depends upon, as phi naught and E are constant, H and E constant, stopping potential varies linearly with frequency of incident radiations and is different for different metals. Stopping potential depends upon intensity of incident radiation, frequency of incident radiations, and is different for different metals. And one more characteristics about instantaneous effect. As soon as radiations are incident on metal surface, energy of photons is transferred to electrons and emission of electron takes place within time lag. Thus, photoelectric effect is an instantaneous process. म्हणजे हे जे आइन्स्टाईनचं इक्वेशन आहे याच्या आधारे आपण ह्या सर्व फोटोइलेक्ट्रिक कॅरेक्टरिस्टिक्स एक्सप्लेन केल्या. क्वेश्चन हा महत्वाचा आहे. क्वेश्चन असा असतो, एक्सप्लेन आइन्स्टाईन्स फोटोइलेक्ट्रिक इक्वेशन अँड कॅरेक्टरिस्टिक्स ऑफ फोटोइलेक्ट्रिक इफेक्ट ऑन आइन्स्टाईन्स फोटोइलेक्ट्रिक इक्वेशन. पहिले हे इक्वेशन तयार करायचं आणि मग याच्या आधारे ह्या कॅरेक्टरिस्टिक्स आपल्याला एक्सप्लेन करता येतात. दिस इज अबाउट फोटोइलेक्ट्रिक इफेक्ट, आइन्स्टाईन्स फोटोइलेक्ट्रिक इफेक्ट लाईक दिस. यानंतर पुढची टर्म आहे ती म्हणजे फोटोइलेक्ट्रिक सेल. फोटोइलेक्ट्रिक सेल, पण हा भाग आपल्या सिलेबस मधून डिलीट झालेला आहे. सध्या तर आपल्याला तो काय स्टडी करायचा नाही. कोणता? फोटो इलेक्ट्रिक सेल. त्यानंतर ऍप्लिकेशन्स ऑफ फोटो इलेक्ट्रिक सेल, त्याचं कन्स्ट्रक्शन, थिअरी वगैरे हा पूर्णपणे भाग डिलीट झालेला आहे. पण त्याच्या पुढचा एक भाग आपल्यासाठी महत्वाचा आहे, तो म्हणजेच अबाउट डी ब्रॉगली hypothesis. De Broglie, Broglie hypothesis. De Broglie hypothesis. हे मात्र आपल्याला ह्या वर्षी आहे. De Broglie hypothesis. According to De Broglie's hypothesis, every moving particle is associated with wave. Every moving particle is associated with wave. This wave is called as De Broglie wave or matter wave. According to De Broglie hypothesis, every moving particle is associated with wave. Such a wave is called as De Broglie wave or matter wave. Now, that's a derivation, your expression. See, De Broglie wave or wavelength of De Broglie wave. According to Planck quantum theory, quantum theory, if H, that is Planck constant, mu, that is frequency of incident radiations, H Planck constant, mu frequency of photons म्हणा, and lambda, that is wavelength of wave. Lambda, that is wavelength of wave. According to Planck quantum theory, if H Planck constant, mu frequency of photons, lambda wavelength of wave, then energy of photon E is equal to H mu. This is energy of photon. But if photon is considered as particle, suppose that this photon is considered as particle moving with velocity v, then according to Einstein's energy mass relation, energy of photon is equal to mv, mass into velocity, or mv square. खरं तर रिलेशन असतं एनर्जी मास रिलेशन इज इक्वल टू mc स्क्वेअर, वेअर c इज वेलोसिटी ऑफ फोटॉन. इथं आपण काय करतो, फोटॉन ऍज अ पार्टिकल घेतोय. इफ फोटॉन इज कन्सिडर्ड ऍज पार्टिकल ऑफ वेलोसिटी v, then energy of photon must be mv square. From these two equations, suppose this is our equation number 2. Here equation, energy of photon by Planck quantum theory. If photon is considered as particle moving with velocity v, then according to Einstein's energy mass relation, energy of photon mv square. समजा ही दोन इक्वेशन्स आपण कंपेअर केली. फ्रॉम इक्वेशन्स 1 and 2, h mu is equal to mv square. But frequency is nothing but velocity divided by wavelength, h into phi divided by lambda. Since phi is equal to mu lambda, velocity is equal to frequency into wavelength, and therefore h phi divided by lambda is equal to m phi square. एका फिला एक फी केला, एच ला इथं खाली आणलं तर मग किंवा लॅम्बडाला वरती घ्या, एम ला खाली घ्या, देअरफॉर वेवलेंथ लॅम्बडा इज इक्वल टू एच डिवाइडेड बाय एम फी. दिस इज डी ब्रॉगली वेव associated with moving particle. This is de Broglie wave of moving particle. Lambda is equal to h divided by m into v. H Planck constant, m mass of particle, v velocity of particle. आता हेच इक्वेशन आपण इलेक्ट्रॉनला कन्सिडर करूया. हेच इक्वेशन समजा आपण इलेक्ट्रॉनला कन्सिडर केलं. बघा नाव कायनेटिक एनर्जी ऑफ मूव्हिंग पार्टिकल 1/2 mv स्क्वेअर. कायनेटिक एनर्जी 1/2 mv square, and therefore E is equal to 1/2 mv square, which implies phi is equal to root 2E divided by m. root 2E divided by m. समजा ही व्हॅल्यू जर आपण इथं पुट केली तर मग लॅम्बडा इज इक्वल टू एच डिवायडेड बाय एम इंटू रूट 2E डिवायडेड बाय एम. इथं एम डिवाइड बाय रूट एम म्हणजे रूट एम, ह्या दोघांना टाका. देअरफॉर लॅम्बडा इज इक्वल टू एच डिवायडेड बाय रूट 2ME. काय केलं इथं आपण? काय केलं? एम डिवाइड बाय रूट एम म्हणजे रूट एम, हा रूट एकत्र केला. If suppose a charge q considered as particle is accelerated by potential phi, if charge q is accelerated by potential phi, then work done or energy is equal to, what is work? That is potential into charge. Work is nothing but potential into charge, and therefore wavelength of moving electron lambda is equal to h divided by root 2m into q into phi, where phi that is potential. आता यामध्ये h कॉन्स्टंट आहे, m मास ऑफ इलेक्ट्रॉन, q चार्ज ऑन इलेक्ट्रॉन, ॲज ऑल दिस टर्म्स आर कॉन्स्टंट. समजा ह्या सर्व व्हॅल्यू सबस्टिट्यूट केल्या तर मग लॅम्बडा इज इक्वल टू 12.27 एंगस्ट्रॉम युनिट डिवाइडेड बाय रूट phi. Phi means stopping potential, and at potential phi is equal to 54 volt. Wavelength of this wave becomes 1.67 angstrom unit, and this is actually wavelength of wave, de Broglie wave associated with moving electron or accelerated electron. This is about de Broglie hypothesis. इथं काय केलं आपण? de Broglie वेव तयार केलं. पहिलं एनर्जी ऑफ फोटॉन. इफ फोटॉन इज पार्टिकल, देन अकॉर्डिंग टू आइन्स्टाईन्स एनर्जी मास रिलेशन इज इक्वल टू एम स्क्वेअर. ही दोन इक्वेशन्स कंपेअर केली, हे तयार केलं. दिस इज de Broglie वेव. आता हेच इक्वेशन इन टर्म्स ऑफ कायनेटिक एनर्जी 1/2 mv². फी बनवला, मिळालेला फी ठेवून लॅम्बडा बनवलं. दिस इज इक्वेशन ऑफ वेवलेंथ ऑफ वेव or de Broglie wave, wavelength of de Broglie wave. In case of electrons, if charge q is accelerated by potential v, जर याला आपण एवढं पोटेन्शियल केलं तर त्याच्यावरती निर्माण होणार वर्क और वर्क डन, दॅट इज चार्ज इनटू पोटेन्शियल. ही व्हॅल्यू इथं ठेवा. h प्लॅंक कॉन्स्टंट, m मास, q चार्ज, ऑल दिस टर्म्स आर कॉन्स्टंट. समजा त्या जर व्हॅल्यू त्या ठिकाणी ठेवल्या तर ही टोटल व्हॅल्यू तयार होते 12.27 अँगस्ट्रॉम युनिट. खाली राहिलं रूट फी. फीला काय म्हणतात? ऍक्सेलरेटेड पोटेन्शियल. ऍट फी इज इक्वल टू 54 व्होल्ट. वेवलेंथ बिकम्स 1.67 अँगस्ट्रॉम युनिट. This is wavelength of de Broglie wave associated with accelerated electron. ओके, तर आपल्याला एवढाच भाग फक्त या टॉपिक मध्ये आहे. डी ब्रॉग्ली हायपोथेसिस वगैरे बाकीचा पूर्णपणे भाग डिलीट झालेला आहे. सध्या एवढंच तुम्ही करायचे. ओके.